So 3, 5, and 6, a new and improved quiz for 2025 into the pattern here. 1 is energy, 2 is potential energy, 3 is kinetic energy, 4 is heat energy, 5 is calorie or joule, doesn't matter who's in which spot, but that's our 2 options. Specific heat is 7. Law of conservation of energy is 8, and the law of conservation of mass is 9, and that is our new ones. Anybody have questions about new ones? If you're in 12th grade, you might be having a physics flashback right about now, because that's all words that we've had.
Yep.
If you have not been through physics, just try to stash those away so that a year from now you can use those words all back again in physics.
They will be important.
All coming back around again. Nothing on those? Okay, then molecule is the smallest part of a pure substance or some such word like that that can exist and undergo chemical changes. 11, molecules are bigger. 12 is chemical formula for one. Molecular formula, I think, is the other one that I don't prefer. 13 is the law of constant composition was 1. And then what's the other one? Law of definite proportions. So pick one of those, doesn't
Which
matter.
one's the, like, what are the 2 options for 12?
12 was molecular formula or chemical formula.
Okay. Which one do you put on?
Doesn't matter. 14 is that they lose their own identity. 15, a physical property is one that you can measure without a change of composition, or you can measure it without forming a new substance, something like that. A chemical property is one you can only measure or observe or know about by having a change of composition or by producing a new substance. So you have some wiggle room on how you want to explain that. Physical property examples, there were a bunch, like color, taste, smell. It can melt, boil, that stuff. Chemical properties would be like you can burn it, you can bake it, you can, something that involves something new coming out. Physical change, it's the same sort of like concept. It's a change that doesn't produce a new substance. It's a change that doesn't change the composition. A chemical change is a change that does change the composition or does produce a new substance. So that's kind of repetitive compared to 15 to 18 again. And then you can reuse some of the same stuff. Physical changes is like boiling, melting, cutting, crumpling, folding, one of those things. Chemical change, that would be like cooking, burning, rusting, some mix, anything that involves chemical reactions, that's what those are. 23, the difference is property is stated in terms of being a fact. The change is like an action or a process, something like that. Question about those?
Which I'm not gonna lie, I thought the example said boiling wood.
Next quiz up, easiest way to describe it, because I do have some math to do and I don't know how time's going to hold up, is just to hand you this. So, next quiz, here you go. And I'm going to do some math, I think, in the midst of doing this at the same time. I think math time out, and then I'll go back to the paper I just handed you that previews the 3-7 quiz. So here's the way I would do the math. I would go ahead and do the math physics style of memorize an equation that's not in this book and just plug the right number in the right spot and do math. Okay? If you like that, you're going to enjoy physics. If you don't like that, there is a dimensional analysis way to do these, and the book is going to do that, and I'm not going to go through that because I just don't want to do it that way. But if you like dimensional analysis, if this confuses you, go ahead and do it that way. I'm not going to complain about it, but I'm going to go with, let's learn this equation and just deal with this. So, anybody physics memories, what do any of these variables stand for?
M is mass.
M is mass. Mass can be measured either with grams or kilograms?
C specific.
The C is our new thing called the specific heat, which I'll explain in just a minute. And the unit, this is gonna come to you from a table in the book.
T's temperature.
T
Well,
is
it's change in temperature.
a temperature change. So what we're normally gonna have to do to figure that out is what math? Usually subtract stuff. And then a thought on this? What type of energy? Heat energy, which is measured in either joules or calories. So here's the first thing that you're going to want to do is check your units. Grams are friendly with calories. So if you have grams and calories in the same story, just put the numbers in, you're good. If you have kilograms and joules in the same story, just plug them in, you're good. But if you get a mismatched pair, you're gonna adjust one. But heat can be a couple units, mass can be a couple units, make sure they fit specific heat. Get it from a table, temperature change, we're gonna subtract. So I set my book down here. If you wish, it'll help if you join me on page 65. So 65 has a table of specific heats. And if you look through these numbers, the highest number in the table for these 6 things they pick is water. Water has the highest specific heat. What that means is water does not easily change its temperature. It's not easy to warm it up. It's not easy to cool it down. Water gets a temperature, water gets an amount of heat, and water likes to keep it. Water does not like to change. Any of you swimming pool owners, you know that that is true. You open your pool, you throw on there your solar cover or whatever you do, and the water is really pretty uncooperative. Okay, it does not want to play with you. Metals are very cooperative to change their temperatures. So if we look at this table, the lowest specific heat is lead. Silver is second in line. Aluminum is probably the one you deal with in your life the most. So if you think about your kitchen cooking experiences, aluminum heats up fast, cools down fast. It just does. So I don't know if you've ever put something into your oven on a thin piece of aluminum foil. You need to take it out with like pot holders. But if you set that aluminum foil down for like maybe 10 seconds, you can touch the foil with your bare hands. Maybe it's 20 seconds, maybe it's 30. Don't go home and try this. But it doesn't take very much time before you can touch that foil. Like everything came out of the oven at 400. Give it not much time and the aluminum is touchable. That heat is gone. But like the pizza is still sizzling at you. Don't touch the pizza. Likewise, if you put water in a pot and you put it on your stove and you ratchet it up to high, you go back a few seconds later and touch the metal pot, that's an ouchie. But if you put your hand in the water for a limited amount of time, you'll be okay. Don't try it just for the fun of it, but like that is a thing. Like the water takes a lot longer to heat up than the metal does. That's what this specific heat is about. Okay, so something with a really, really low specific heat is going to heat up and cool down really, really fast. Something with a high specific heat like water, it's going to take a while. That's why your car has like water in the antifreeze coolant tank. Like your metal engine heats up really, really, really fast. And the water in there makes it not heat up so fast. It makes your car not like go crazy hot and overheat all the time. But that's what the specific heats are about. That's what the table is about. But every problem you're going to have to grab the right number from the table. Unlike physics, we only were given, I believe, the one column of numbers. I think we made everything kilograms, like always. Mm-hmm. I don't think we ever did the variations. This is giving you 2 columns for 2 variations. You just have to grab the right thing. Well, example 3.3, what I would do first reading this question is go blah, 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 calories matter to me, blah, 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 grams matter to me. I would scope out those 2 unit options and reach a conclusion. Calories and grams, are those friends or no? calories and grams?
Yeah.
Yes, because I've punctuated those that way. So then we just plug the right number in the right spot as they are. So what's the heat number in that sentence? The calorie or joule number?
75.
Somebody say again?
75.
75. Mass is given to us? 10. They named some sort of an element. What element is this? Or do we
It
not
just
know?
says calculate specific.
Okay, we don't know, so just call that X because we don't know
And
it.
then 35.
Temperature change is 35 if we subtract temperatures. And then it's just a matter of a quick algebra thing, like multiply those numbers and then do the opposite. Since it's multiplying, you'd have to
Bye.
divide and get what you get. Question about that one? So let's do another one. So this says like blah, blah, blah joules, blah, blah, blah kilograms, joules and kilograms, are they friends? Yes, so let's just roll. Do they give you the joule number? No. So they must give you the mass.
0.12.
They have to tell you what it's made of. Sodium chloride. So we go to the table and look up sodium chloride, but we have to use the right column. We're presently working the joule kilogram column. So 8.54 times 10 to the 2, which in simpler terms is 854. And then temperature change,
Um,
60, just subtract it. It doesn't matter if it's Celsius or Kelvin, any temperatures will work. Fahrenheit won't work, I don't think they give you Fahrenheit.
and then multiply.
Just multiply, the X is already alone, just multiply. Something about that? Okay, so let's do another one. Blah, blah, blah joules, blah, blah, blah grams. Good, bad?
Bad.
Bad. So change the grams. Change the grams to kilograms.
0.25.
It is 0.25. So when we plug that in, we're going 0.25 for the mass. We don't know the joules. They tell you what it's made out of. Lead, so we go look up the lead number from the right column.
1.3 times 10%.
In other words, 130. They have to tell you the temperature change. 100. All by the numbers. Something about
Why do
that.
they give it to you in scientific notation?
I don't know.
I only do it for one column.
Yeah, feel free in the book to just move all the decimals 2 or 3 places and have like a normal number if that's gonna make you mad. Kind of makes me mad. I don't want to hit the scientific notation button. 36, blah, 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 grams, blah, 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 calories. So what do you think about that? That's good. I like that. So we want to find the grams. So that's in the mass position. We know the calories was
800.
800. What's it made out of?
Aluminum.
Aluminum. So we'll look up aluminum, but we're on the gram calorie family now for aluminum.
0.217.
Agreed. They have to tell you the temperature change.
40.
40. And then in terms of algebra, multiply them, there's an in-between step.
And then divide.
800 divided by that, and we have it. Something there. One more. Blah, blah, blah grams, blah, blah, blah joules.
No.
No. So I would say just live with the joules for now, because we'd like to just use this equation. When the joules gives you an answer, it's going to give you an answer in terms of kilograms.
So just-
Then let's change that later. Okay, but 3.25 times 10 to the third is 3250 on the joules. Mass, we don't know. So they have to tell you what this is made out of.
Water.
Water, so
1.
water.
Well, it's 4.18 times 10.
Yeah, we're living with the joules for now. So joules for now, we got to do 4180. Temperature
And then-
change
20.
is 20. So as an in-between step, multiply them. Then this divided by that. would get you a hopefully .0389. Just don't lose your train of thought concentration. Tie a string on your finger or something to remind you. This was joules, so this is kilograms, and they want
This is
grams.
38.0.
So we're gonna do that triple bounce, because 3 zeros in kilo, 38.9 would be for the win on that. Question about any of that business, math in it? I have a sheet of notes that like describes that in about as much detail, if not more than what I just said. I think more, because I think there's a year before the YouTube videos were being used by me that I missed school for some reason, and they just had to learn from this handout, not from me even being present or on video. Is there anybody that would want a handout that sort of like describes what that was? You pass those that way for those customers, one that way for that customer. Anybody else want a handout that kind of like retreads that all? Scoot that to the side. Then let's look preview quiz. The preview paper that I gave you. So what's up for next time is read 3.7. We're only going to do a chemistry quiz, no elements quiz tomorrow. We're going to give that a timeout till Friday. We're going to go, the Friday version will be all of them, but in reverse, so that's the harder way. So practice your spelling for a couple days. Tomorrow it's just this paper that I already gave you. So reading 3.7, there's going to be 8 new fill-in points from reading 3.7. Very well marked. There's no really well-kept secrets on that. And then there's the 2 points from 9 and 10. You need to read a whole box about silicon and like be ready to say 2 things because you read the whole box on silicon. And then you can see exactly what the other questions are. Some of them are today's backward, but you can just use today's definitions as well as I can say them to you and just make your own study point. And then I threw 3 bonus points on there. For extra credit, you could tell me that 4.18 joules make 1 calorie. My high recommendation is when the units are misfit, don't try to change joules to calories using the 4.184. Like, that's harder. Just change the gram kilogram thing by moving the decimal 3 spots. That's a lot simpler. But it's not a bad thing to know that 1 calorie is the same as 4.184 joules. The other extra credit, just to make the equation more useful, calories go with grams, joules go with kilograms, if we're trying to do this the equation way. And then around 28, 29, tomorrow on that, there is a law of conservation of mass energy, which was come up with by Einstein and the very famous equation E equals mc squared. You can turn energy into mass or vice versa using that equation. It's not easy. But 3.7 quiz is that's the only quiz tomorrow. Homework life from this, the mathy part will go 12 to 17, and I don't think it's like an ABCD thing. No, it's not. It's a true 12 to 17, so that's 6 questions. We did 5, so it's like that size, 12 to 17. But there is some scattered, like 1, R through Z, 2, C, and D. There's the usual scattered vocabulary, but 12 to 17 will be math of that size and difficulty level. Anybody question about things? In terms of other illumination here, energy, worth a mention, even though it doesn't make the quiz, there's a lot of kinds of energy. So physics people probably remember mechanical energy, electrical energy, light energy, heat energy. There's also chemical energy and radiant energy, but none of that's going to make a quiz. The rest of this I feel like is either kind of like self-explanatory or it's things that you've had before. I guarantee you in younger science you've had kinetic energy as energy of motion. There's no way you're hearing that for the first time. That had to have been covered by somebody other than me before you got here. Anybody questions about any of the info in 5 and 6, understanding what's up? What is new to your life, some of you, is specific heat. And that's, again, the measurement of how hard or easy it is to heat or cool down some sort of element, depending on what its deal is. That's it for that. Shut that down.